Chapter 2, Part 2 of Airplane Flying Handbook, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jennifer Dorr. Airplane Flying Handbook, Volume 1 by Federal Aviation Administration. Ground Operations, Part 2. Ground Operations. It is important that a pilot operates an airplane safely on the ground. This includes being familiar with standard hand signals that are used by ramp personnel. See Figure 2-9. Engine starting. The specific procedures for engine starting will not be discussed here, since there are as many different methods as there are different engines, fuel systems, and starting conditions. The before engine starting and engine starting checklist procedures should be followed. There are, however, certain precautions that apply to all airplanes. Some pilots have started the engine with the tail of the airplane pointed toward an open hangar door, parked automobiles, or a group of bystanders. This is not only discourteous, but may result in personal injury and damage to the property of others. Propeller blast can be surprisingly powerful. When ready to start the engine, the pilot should look in all directions to be sure that nothing is or will be in the vicinity of the propeller. This includes nearby persons and aircraft that could be struck by the propeller blast or the debris it might pick up from the ground. The anti-collision light should be turned on prior to engine start, even during daytime operations. At night, the position, navigation lights should also be on. The pilot should always call "clear" out of the side window and wait for a response from persons who may be nearby before activating the starter. When activating the starter, one hand should be kept on the throttle. This allows prompt response if the engine falters during starting and allows the pilot to rapidly retard the throttle if revolutions per minute, RPM, are excessive after starting. A low RPM setting, 800 to 1000, is recommended immediately following engine start. It is highly undesirable to allow the RPM to race immediately after start, as there will be insufficient lubrication until the oil pressure rises. In freezing temperatures, the engine will also be exposed to potential mechanical distress until it warms and normal internal operating clearances are assumed. As soon as the engine is operating smoothly, the oil pressure should be checked. If it does not rise to the manufacturer's specified value, the engine may not be receiving proper lubrication and should be shut down immediately to prevent serious damage. Although quite rare, the starter motor may remain on and engaged after the engine starts. This can be detected by a continuous very high current draw on the ammeter. Some airplanes also have a starter engaged warning light, specifically for this purpose. The engine should be shut down immediately should this occur. Starters are small electric motors designed to draw large amounts of current for short periods of cranking. Should the engine fail to start readily, avoid continuous starter operation for periods longer than 30 seconds, without a cool-down period of at least 30 seconds to a minute. Some AFM-POH specify even longer. Their service life is drastically shortened from high heat through overuse. Hand propping. Even though most airplanes are equipped with electric starters, it is helpful if a pilot is familiar with the procedures and dangers involved in starting an engine by turning the propeller by hand. Hand propping. Due to the associated hazards, this method of starting should be used only when absolutely necessary and when proper precautions have been taken. An engine should not be hand propped unless two people, both familiar with the airplane and hand propping techniques, are available to perform the procedure. The person pulling the propeller blades through directs all activity and is in charge of the procedure. The other person, thoroughly familiar with the controls, must be seated in the airplane with the brakes set. As an additional precaution, chocks may be placed in front of the main wheels. If this is not feasible, the airplane's tail may be securely tied. Never allow a person unfamiliar with the controls to occupy the pilot seat when hand propping. The procedure should never be attempted alone. When hand propping is necessary, the ground surface near the propeller should be stable and free of debris. Unless a firm footing is available, consider relocating the airplane. Loose gravel, wet grass, mud, oil, ice, or snow might cause the person pulling the propeller through to slip into the rotating blades as the engine starts. Both participants should discuss the procedure and agree on voice commands and expected action. To begin the procedure, the fuel system and engine controls, tank selector, primer, pump, throttle, and mixture are set for a normal start. The ignition magneto switch should be checked to be sure that it is off. Then, the descending propeller blade should be rotated so that it assumes a position slightly above the horizontal. The person doing the hand propping should face the descending blade squarely and stand slightly less than 1 arm's length from the blade. If a stance too far away were assumed, it would be necessary to lean forward in an unbalanced condition to reach the blade. This may cause the person to fall forward into the rotating blades when the engine starts. The procedure and commands for hand propping are: person out front says, gas on, switch off, throttle closed, brakes set. Pilot seat occupant, after making sure the fuel is on, mixture is rich, ignition magneto switch is off, throttle is closed, and brakes set, says, gas on, switch off, throttle closed, brakes set. Person out front, after pulling the propeller through to prime the engine, says, brakes and contact. Pilot seat occupant checks the brakes set and turns the ignition switch on, then says, brakes and contact. The propeller is swung by forcing the blade downward rapidly, pushing with the palms of both hands. If the blade is gripped tightly with the fingers, the person's body may be drawn into the propeller blades should the engine misfire and rotate momentarily in the opposite direction. As the blade is pushed down, the person should step backward away from the propeller. If the engine does not start, the propeller should not be repositioned for another attempt until it is certain the ignition magneto switch is turned off. The words contact, mags on, and switch off, mags off, are used because they are significantly different from each other. Under noisy conditions or high winds, the words contact and switch off are less likely to be misunderstood than switch on and switch off. When removing the wheel chocks after the engine starts, it is essential that the pilot remember that the propeller is almost invisible. Incredible as it may seem, serious injuries and fatalities occur when people who have just started an engine walk or reach into the propeller arc to remove the chocks. Before the chocks are removed, the throttle should be set to idle and the chocks approached from the rear of the propeller. Never approach the chocks from the front or the side. The procedures for hand propping should always be in accordance with the manufacturer's recommendations and checklist. Special starting procedures are used when the engine is already warm, very cold, or when flooded or vapor locked. There will also be a different starting procedure when an external power source is used. Taxiing. The following basic taxi information is applicable to both nose-wheel and tail-wheel airplanes. Taxiing is the controlled movement of the airplane under its own power while on the ground. Since an airplane is moved under its own power between the parking area and the runway, the pilot must thoroughly understand and be proficient in taxi procedures. An awareness of other aircraft that are taking off, landing, or taxiing, and consideration for the right-of-way of others is essential to safety. When taxiing, the pilot's eyes should be looking outside the airplane, to the sides as well as the front. The pilot must be aware of the entire area around the airplane to ensure that the airplane will clear all obstructions and other aircraft. If at any time there is doubt about the clearance from an object, the pilot should stop the airplane and have someone check the clearance. It may be necessary to have the airplane towed or physically moved by a ground crew. It is difficult to set any rule for a single safe taxiing speed. What is reasonable and prudent under some conditions may be imprudent or hazardous under others. The primary requirements for safe taxiing are positive control, the ability to recognize potential hazards in time to avoid them, and the ability to stop or turn where and when desired, without undue reliance on the brakes. Pilots should proceed at a cautious speed on congested or busy ramps. Normally, the speed should be at the rate where movement of the airplane is dependent on the throttle. That is, slow enough so when the throttle is closed, the airplane can be stopped promptly. When yellow taxiway centerline stripes are provided, they should be observed unless necessary to clear airplanes or obstruction. When taxiing, it is best to slow down before attempting a turn. Sharp, high-speed turns place undesirable side loads on the landing gear and may result in an uncontrollable swerve or a ground loop. This swerve is most likely to occur when turning from a downwind heading toward an upwind heading. In moderate to high wind conditions, pilots will note the airplane's tendency to weather vane or turn into the wind when the airplane is proceeding crosswind. When taxiing at appropriate speeds in no-wind conditions, the aileron and elevator control surfaces have little or no effect on directional control of the airplane. The controls should not be considered steering devices and should be held in a neutral position. Their proper use while taxiing in windy conditions will be discussed later. See Figure 2-10. Steering is accomplished with rudder pedals and brakes. To turn the airplane on the ground, the pilot should apply rudder in the desired direction of turn and use whatever power or brake that is necessary to control the taxi speed. The rudder pedal should be held in the direction of the turn until just short of the point where the turn is to be stopped. Rudder pressure is then released, or opposite pressure is applied as needed. More engine power may be required to start the airplane moving forward or to start a turn than is required to keep it moving in any given direction. When using additional power, the throttle should immediately be retarded once the airplane begins moving to prevent excessive acceleration. When first beginning to taxi, the brakes should be tested for proper operation as soon as the airplane is put in motion. Applying power to start the airplane, moving forward slowly, then retarding the throttle and simultaneously applying pressure smoothly to both brakes does this. If braking action is unsatisfactory, the engine should be shut down immediately. The presence of moderate to strong headwinds and/or a strong propeller slipstream makes the use of the elevator necessary to maintain control of the pitch attitude while taxiing. This becomes apparent when considering the lifting action that may be created on the horizontal tail surfaces by either of those two factors. The elevator control in nosewheel type airplanes should be held in the neutral position, while in tailwheel type airplanes, it should be held in the aft position to hold the tail down. Downwind taxiing will usually require less engine power after the initial ground roll is begun, since the wind will be pushing the airplane forward. See Figure 2-11. To avoid overheating the brakes when taxiing downwind, keep engine power to a minimum. Rather than continuously riding the brakes to control speed, it is better to apply brakes only occasionally. Other than sharp turns at low speed, the throttle should always be at idle before the brakes are applied. It is a common student error to taxi with a power setting that requires controlling taxi speed with the brakes. This is the aeronautical equivalent of driving an automobile with both the accelerator and brake pedals depressed. When taxiing with a quartering headwind, the wing on the upwind side will tend to be lifted by the wind unless the aileron control is held in that direction. Upwind aileron up. See Figure 2-12. Moving the aileron into the up position reduces the effect of the wind striking that wing, thus reducing the lifting action. This control movement will also cause the downwind aileron to be placed in the down position, thus a small amount of lift and drag on the downwind wing, further reducing the tendency of the upwind wing to rise. When taxiing with a quartering tailwind, the elevator should be held in the down position, and the upwind aileron down. See Figure 2-13. Since the wind is striking the airplane from behind, these control positions reduce the tendency of the wind to get under the tail and the wing and to nose the airplane over. The application of these crosswind taxi corrections helps to minimize the weather vaning tendency and ultimately results in making the airplane easier to steer. Normally, all turns should be started using the rudder pedal to steer the nose wheel. To tighten the turn after full pedal deflection is reached, the brake may be applied as needed. When stopping the airplane, it is advisable to always stop with the nose wheel straight ahead to relieve any side load on the nose wheel and to make it easier to start moving ahead. During crosswind taxiing, even the nose wheel type airplane has some tendency to weather vane. However, the weather vaning tendency is less than in tailwheel type airplanes because the main wheels are located farther aft, and the nose wheel's ground friction helps to resist the tendency. See Figure 2-14. The nose wheel linkage from the rudder pedals provides adequate steering control for safe and efficient ground handling, and normally only rudder pressure is necessary to correct for a crosswind. Before takeoff check. The before takeoff check is the systematic procedure for making a check of the engine, controls, systems, instruments, and avionics prior to flight. Normally, it is performed after taxiing to a position near the takeoff end of the runway. Taxiing to that position usually allows sufficient time for the engine to warm up to at least minimum operating temperatures. This ensures adequate lubrication and internal engine clearances before being operated at high power settings. Many engines require that the oil temperature reach a minimum value as stated in the AFM-POH before high power is applied. Air-cooled engines generally are closely cowled and equipped with pressure baffles that direct the flow of air to the engine in sufficient quantities for cooling in flight. On the ground, however, much less air is forced through the cowling and around the baffling. Prolonged ground operations may cause cylinder overheating long before there is an indication of rising oil temperature. Cowl flaps, if available, should be set according to the AFM-POH. Before beginning the before takeoff check, the airplane should be positioned clear of other aircraft. There should not be anything behind the airplane that might be damaged by the prop blast. To minimize overheating during engine run-up, it is recommended that the airplane be headed as nearly as possible into the wind. After the airplane is properly positioned for the run-up, it should be allowed to roll forward slightly so that the nose wheel or tail wheel will be aligned fore and aft. During the engine run-up, the surface under the airplane should be firm, a smooth, paved, or turf surface if possible, and free of debris. Otherwise, the propeller may pick up pebbles, dirt, mud, sand, or other loose objects and hurl them backwards. This damages the propeller and may damage the tail of the airplane. Small chips in the leading edge of the propeller form stress risers or lines of concentrated high stress. These are highly undesirable and may lead to cracks and possible propeller blade failure. While performing the engine run-up, the pilot must divide attention inside and outside the airplane. If the parking brake slips or if application of the toe brakes is inadequate for the amount of power applied, the airplane could move forward unnoticed if attention is fixed inside the airplane. Each airplane has different features and equipment, and the before takeoff checklist provided by the airplane manufacturer or operator should be used to perform the run-up. After landing. During the after landing roll, the airplane should be gradually slowed to normal taxi speed before turning off the landing runway. Any significant degree of turn at faster speeds could result in ground looping and subsequent damage to the airplane. To give full attention to controlling the airplane during the landing roll, the after-landing check should be performed only after the airplane is brought to a complete stop, clear of the active runway. There have been many cases of the pilot mistakenly grasping the wrong handle and retracting the landing gear instead of the flaps, due to the improper division of attention while the airplane was moving. However, this procedure may be modified if the manufacturer recommends that specific after-landing items be accomplished during landing rollout. For example, when performing a short-field landing, the manufacturer may recommend retracting the flaps on rollout to improve braking. In this situation, the pilot should make a positive identification of the flap control and retract the flaps. Clear of runway. Because of different features and equipment in various airplanes, the after-landing checklist provided by the manufacturer should be used. Some of the items may include flaps, identify and retract, cowl flaps, open, propeller control, full increase, trim tabs, set. Parking. Unless parking in a designated supervised area, the pilot should select a location and heading which will prevent the propeller or jet blast of other airplanes from striking the airplane broadside. Whenever possible, the airplane should be parked headed into the existing or forecast wind. After stopping on the desired heading, the airplane should be allowed to roll straight ahead enough to straighten the nose wheel or tail wheel. Engine shutdown. Finally, the pilot should always use the procedures in the manufacturer's checklist for shutting down the engine and securing the airplane. Some of the important items include: set the parking brakes on, set throttle to idle or 1000 RPM. If turbocharged, observe the manufacturer's spool down procedure. Turn ignition switch off, then on at idle to check for proper operation of switch in the off position. Set propeller control, if equipped, to full increase. Turn electrical units and radios off. Set mixture control to idle cutoff. Turn ignition switch to off when engine stops. Turn master electrical switch to off. Install control lock. Post-flight. A flight is never complete until the engine is shut down and the airplane is secured. A pilot should consider this an essential part of any flight. Securing and servicing. After engine shutdown and deplaning passengers, the pilot should accomplish a post-flight inspection. This includes checking the general condition of the aircraft. For departure, the oil should be checked and fuel added if required. If the aircraft is going to be inactive, it is a good operating practice to fill the tanks to the top to prevent water condensation from forming. When the flight is completed for the day, the aircraft should be hangared or tied down and the flight controls secured. End of Ground Operations Part 2.